All right, now that we've talked about simplifying algebraic expressions, we're going to be now performing some operations with these expressions, and we're going to be starting with adding linear expressions. And a linear expression is just any algebraic expression in which the variable is raised to the first power. So really it's any expression that contains a variable and it doesn't have an exponent besides 1. There's no squared to the third power, to the fourth power. There's no exponents in the expression other than an exponent of 1. So I give some examples here of quite a few linear expressions. We have x plus 1 is a linear expression because x is raised to the first power. Z by itself is a linear expression, 19r. 4 minus 3x, 4w plus 2w minus 8. Those are all examples of linear expressions. So we're going to be taking combinations of these expressions and we're going to be adding them together. So how do you add linear expressions? Well, it's really a piece of cake. You really just need to add the like terms from each expression. So we're going to, again, be identifying like terms and then just combining them. We're going to be adding the like terms that we have in each of the expressions. So let's take a look at a couple of examples here of some linear expressions. Here I have x minus 3 and x minus 4, and I'm going to be adding these two expressions together. So what I'm looking for here are the like terms in each pair of parentheses. So I have the x's here that are like terms, and I'm going to be adding them together. That plus sign applies to everything in the parentheses to the right of it. So it's basically x plus x here. And then I'm going to add my constants together here. So remember, just like we did with our other expressions, we're going to include that sign in front along with it. So it's basically going to be like minus 3 plus a negative 4 is how that's going to turn out. So here's my expression now expanded without the parentheses, and then I'm going to go ahead and combine those like terms. X plus x is 2x, and negative 3 plus negative 4 is negative 7. So 2x minus 7 is my simplified expression. So I've added those two expressions together, 2x minus 7 or 2x plus negative 7. But again, we want to simplify those double signs and not have to deal with those. The next example here, x's are in both of these expressions. So I'm going to be combining those. So I'm going to apply that plus sign in between. So it's negative x plus negative 3x. And then there's a constant in the first expression, but there is no constant in the second expression. So it's basically like adding 0. So positive 1 plus 0, that's just going to be a plus 1 then when I add those together. And then when I go to simplify this expression, negative x plus negative 3x is negative 4x. That's like negative 1 plus negative 3. And then just tacking on the constant plus 1. And again, those are not like terms, so this is simplified. So really pretty easy, just combining like terms when we're adding these expressions together. Here are a couple more just to get the hang of doing this. So again, I'm identifying my like terms here in the expressions. Negative 2x plus 8x are the x terms, and then my constants, I have a positive 4 plus a negative 4. So plus 4 plus a negative 4. And then those two are basically going to cancel each other out. They're additive inverses. So my constants basically go away to 0. And then when I add my x terms together, negative 2x plus 8x is 6x. So I have 6x plus 0, or just 6x. In the next one, again, my x terms, negative 4 plus 5x, negative 4x plus 5x. And my constants, I'm going to think of that as a negative 1 plus a negative 3, or minus 1 plus a negative 3. When I combine my x terms together, negative 4x plus 5x is 1x, or just x. Again, I don't need to put the 1 there as the coefficient. And then when I combine my constants, I'm thinking of this as a negative 1 plus negative 3. That's negative 4, so it would be minus 4. X minus 4 is my result. And again, those are not like terms, so I am simplified. Okay. Again, piece of cake. So here, let's take a look at an example of applying this concept. A rectangle has side lengths of 5x minus 1 units and 2x plus 1 units. Write and simplify an expression for the perimeter of the rectangle. So recall the perimeter is the distance all the way around. So the bottom of this rectangle is 5x minus 1. That means the top is also 5x minus 1. The right side, or the height, is 2x plus 1. That means the left side is also 2x plus 1. So really, if I'm going to write an expression for the entire distance around, I have two sets of 5x plus 1. So I'm going to write 2 times 5x minus 1. And then I'm going to add that to the 2x plus 1. So I have 2 times 2x plus 1. And that expression represents the perimeter of the rectangle. Now it says to simplify that, so I need to get rid of the parentheses and combine like terms. So I'm going to use the distributive property to simplify this first expression, and that gives me 10x minus 2. That's both of those terms times 2. And I'm going to do the same thing to the second expression. I'm going to take everything in the parentheses times 2. 2 times 2x is 4x. And 2 times 2 is 2. And then now, again, I have two expressions, two linear expressions that I'm going to be adding together. And then I'm going to look for my like terms, 10x plus 4x. Those are my x terms. And then my constants, -2 plus a +2, or -2 plus 2. And again, those constants are going to go away. They're going to cancel out to 0, additive inverses. And then when I add my x terms together, 10x plus 4x is 14x. So 14x plus 0, or just 14x, is the expression that represents the perimeter of the rectangle. And then it says find the perimeter of the rectangle if the value of x is 5.4 units. So now I'm going to use this simplified expression and substitute 5.4 in for x. 14 times 5.4 is 75.6 units for the perimeter if x is 5.4. Okay, so adding linear expressions, pretty easy to do. Again, combining like terms in each expression.